What I love about video games is sharing good moments with my friends and family. I remember epic moments playing GoldenEye, Diddy Kong Racing and Mario Party on the Nintendo 64. But little by little, local multiplayer has been replaced by online multiplayer, which is great but requires one device and game per player, not ideal when meeting friends. Ultimately, there are board games like Dixit and Codenames. It is a great alternative. But you need to bring the game, explain the rules, it needs some preparation. That's where multiplayer streaming games are the best of both worlds solution. You have one screen displaying the main game board, and players can join using their smartphone as a controller. The most well-known are Use Your Words and Jackbox party games. That's a great way to play together locally, but also to connect with your audience on live streaming sessions. Let's build our own browser game using JavaScript with React Three Fiber and Playroom for the multiplayer. We are a crew of pirates who just found a treasure. There are 3 gems to share, but pirates are pirates and we want it all. We have 3 rounds, and with our cards we can choose to grab a gem, or to punch another player to make it drop one, or hide inside a barrel to avoid being punched and keep our treasure. During this video tutorial, I will explain everything step by step to build this game, such as creating a multiplayer game engine, making a streaming session with mobile controllers, creating cards using AI, and finding 3D assets to render our game. You have the choice to reproduce it, enhance it, or use what you will learn to create your own game with your own rules and universe. I count on you to make the next funniest game I can play with my friend. Let's get started. To create our project, let's use my React Three Fiber template project. Go to Code, copy the HTTPS address, open a terminal, git clone, paste the address, and I will type the folder I want to put it into, and hit enter. Once it's done, open the newly created folder, file open folder, run yarn to install the dependencies, and yarn dev to start the development server. You can open it by clicking on the link. And you should see that 3D cube you can rotate around, which means React Three Fiber is set up correctly. Before implementing our game rules and logic, let's dissect them through this schema. Here we have the different phases of our game. Start game, choose a card, player choice, player action, and end. And throughout those different phases, we will perform different actions to alter our state and create our game logic. When we start the game, we have to init the default state. So it's the setup phase. What we generally do is we shuffle and draw the cards. We init the players, so assigning them 0 gem to reset it, and also to give them the different number of cards, and set up the timer, gems, every variables we need. Okay, when it's done, we go to the choose a card phase. So when we are at this phase, every player will have a set amount of time to play and choose its card. For example, let's say 10 seconds, but you can configure to your needs, or you can even make it to wait until every player choose a card. And then when we are ready, we will go to player choice. So we will start from one player. So let's name it current player turn. Based on the card it chose, either it will be player choice. So when it's a punch, the user will have to choose who it wants to punch. But if it's not, it can go directly to the player action. At the player action, based on the card, if it's a punch, we drop a gem from another player, if it's able to do it. If it's a shield, we update our user state to make it shielded and untouchable by a punch. And if it's a grab, it's grabbing a gem only if one is available. Again, for each phase, we can define an amount of time, let's say 5 seconds for player choice, and also 5 seconds when we display the player action. And when one player is finished, we have to check. Either we didn't go through all players, so we will go back either to player choice or to player action for the next player. So here it's next player action. Or if it was the last player, we will go back to choosing a card. So when we do it, we draw a new card to each player. So we just finished the first round, and then we do it again for round 2, round 3, how many rounds you want. But if it was the last round, then we go to the end and we define who is the winner of the game. Let's start by creating our game engine. So in the source code, we will create a new hook. So inside the source folder, create hooks, and we will name it useGameEngine.jsx. We'll create a boilerplate hook, so const game engine context is equal to react.createContext. We need to import React here. Then below we need to create a provider, so game engine provider. For the moment, we will just return our provider with no value. It contains the children, and we close it. And then we create our useGameEngine method that is using useContext. It returns the context, but if we didn't wrap our component within the provider, it will trigger an error. Now let's wrap our whole application with the game engine provider. Go to main.jsx, and we will wrap the application here with game engine provider here. Now let's go back to our useGameEngine, and we will start by creating our main state that contains all the variables we need for our game engine. First, let's define some useful constants we will need. The time for the cards, so it's when player choose what card they want to play. Player choice is the time player choose which target they attack. Then player action, it's when we will display that a player is doing an action. So they won't need to interact, it will just be display. Let's make it to 3 seconds, but you can adjust it later. Then the number of rounds per game. Let's put it 3 by default, and we export it because we will need it outside the hook. Then the number of gems that are available in the middle of the screen. So they will fight for 3 gems. That's why they will punch the other characters, because if they can't grab them, they need to get them from the user who already have it. And the number of cards per player. Now we have this ready, we need to create our state variable. But because we want it to be multiplayer, let's add our Playroom SDK. To make easily our multiplayer game, we are using the Playroom Kit SDK. Go to Setup, and we just need to install Playroom Kit package. Open the terminal, stop the development server, run yarn, add and Playroom Kit. Now to start a multiplayer session, we need to go to main.jsx, and before rendering our game, we will do insert coin from Playroom Kit, and then we will call our create route to render our game. Later we will use the stream mode, but for the moment we can keep it simple. So now, out of the box, if I open my game, first I have the Playroom Kit lobby, so I can edit my name, change my avatar and the color. I can invite other user. So let's invite, share the link. It's copied in my clipboard. I can open a new tab. Today I'm using Arc to make it easy to show the split screen. I open the other URL, and automatically I have a multiplayer lobby ready to use. There is on the left the host, and on the right another player that joined the server. Now if I click launch, both of them are aware that it started, and we can use our multiplayer state to create multiplayer logic between the different clients. Inside the documentation, you can find the information on how to work with it. So usage with React Three Fiber. You have the different hooks available we can use to create our game. The one that we will mainly use is use multiplayer state. It is a state like when we use React, but the difference is here it's synced between the different clients logged into the same game session. Let's go back to our game engine. And let's create our global state. First, let's create a timer. We have the value, a function to update it like a normal state, but we call use multiplayer state. We set the name over the network and the default value. Then we need to add a round value. It's at what stage of the game we are. Then the phase, which is if we are drawing the card, performing an action, what we saw inside the schema on xCaliDraw, which player turn it is, so starting from player 0 to the number of players. Player start, we change which player is starting the round at each round, so we will make it turn across the different players. The deck, it will contain all our cards. The gems, which is equal to the number of gems available on the game board. And action success, it's just to determine if an action was made successfully or not. It will be useful for the UI part later. And then we get our list of players, so const player is equal to use players list. It's also coming from Playroom Kit. And we can add an additional parameter, which is true. So our component will be re-rendered every time there is a change inside the player list. Then, because the order of the players is very important inside our game, because we are using indexes to know which player turn it is, we need to sort our players list. So what we do is just players.sort, and we compare their ID. So we sort them alphabetically based on their user ID. So we are sure every client has the same list of players ordered, because based on the client, they can be in a different orders initially. Then let's create a game state that will contain all our state variable that we will be able to use with the UI, or just if we want to log the values to know what is happening. Now we have this. We want to make our game state available. So we destructurate game state so they have all the variable. Or we could have wrote all the variable here. But if sometime we want to console log the game state, it's easier to separate it. Now we have all our variables. We just have to create our game logic. So let's start by a use effect. When our component is instantiated, we will call a method named start game. And because the number of player is very important, if a player joins, so on player join, we will also call start game. So we reset the game if a new player joins it. Now let's create our start game method, which will initialize the game, but we must also think that when we want to reset the game, we restart, play again, we will also call that method. So it really has to put all the variables in the starting state. First, we check if we are the host, and this is a method from Playroom Kit. Let's log start game, so we'll be able to visually see before doing the UI. Then we set our timer to be the time of the phase cards, because it will be the first phase. We will choose a random player. It will be the one that will be starting the game. So set player start. We don't want to start every time with the player 0. So we'll take just one inside the list. Then, of course, because it's the one that is starting, we set its index to the same. Then we start at around 1 and we fill our deck of cards. So it's an array containing 16 punch cards, 24 grab cards, and 8 shield cards. Of course, you can adjust to your type of games and the meta you want. Here you have a lot of grab cards, a bit of punch, and a few shield to protect you. And then we set the number of gems to the maximum number, because if we finished a game and player took it, we don't have them anymore, so we reset our game too. Then we iterate through each player and we set their default values. So we set up our player with the player ID. We give it an empty array of cards. We will distribute them later in a separate method. We set its number of gems to 0. We set it to be not shielded. And you can see that we are using true at the end of each set state. It's because we want it to be reliable. The difference between reliable state and not reliable state is explained on Playroom Kit documentation. What it means is when we set it to true, we are sure that the value is passed to the other client. If we don't do it, it can be lost, but it's faster to do it. But it's for games that are frame-based, like an FPS, where you can just get the value at the next frame. But us, the values are very important, so we will always use set state with a true value in the end as the last parameter. So let's finish our user. We set it as a winner is false, and then we distribute the cards. Once we have set up our game, we set the phase to cards. Now we need to create our distribute cards method, which takes the number of cards we want to distribute, because we will reuse it at the end of a turn, because we start with 4 cards. They all play 1 card per turn. At the end of each round, we will give the player a new card. Let's create our distribute card here. It takes the number of cards. Then we do a copy of the current deck. We get through getState to be sure it's the actual value, instead of just using deck variable, because if we didn't have a re-render, maybe the value is not up to date. Then we iterate through each our player. We get their current cards. We iterate through the number of cards we want to distribute. We pick a random card within the deck. Of course, if it was a real game, you would take the one on the top of the deck. Here I chose that method to avoid to shuffle the deck, so you can choose one or the other. Then we push that card to the player cards. We remove it from the deck and we set the state to the player with its new cards. Then we set what is the selected card it has in its end. So we set it to 0 and we set the player target to -1, which is which player it wants to attack. And once we have finished to distribute the cards, we set the new deck because it's the deck of before without the card that has been removed. Now we need to set up our timer that will run every second to go from one phase to another. First, let's use useControls from Leva library to be able to pause it while we are in development. We need to add Leva library for it, so yarn add Leva. When it's finished, yarn dev and hide the terminal. Don't forget to import it. Then to be able to hide or show the control, let's go to app. Next to the canvas, we'll use Leva and we'll use hidden is equal to a condition we will make. So let's create a const debug variable. Let's set it to true for the moment. So are we on debug? So if we are not in debug or if we are not the host, we will add Leva. Otherwise, we display it. Let's have a look at if we work and if we didn't break everything. So yeah, we have our 2 cubes and we can pause or not on the host. So I guess this one is the host. First, we will create a reference to store our timer interval. Then we create a function we name runTimer. Inside, we do a set interval every second and we store it inside our reference. Then if we are not the host, we will return, but we still want to call set interval because if the host is disconnected, another player will be the host, and we want the loop to be seamless and to call the function if it happens. If it is paused, we also return, so the timer won't decrement and we will be able to debug if we need to. Then the new time, it will just be equal to getState of timer -1. We can console log the timer to understand in the console what is happening before we develop the UI. And if the new time is below 0, we will call a function that is named phaseEnd that will perform the different action and lead us to the new phase like we saw in the schema. If it's not the case, we'll just set the timer to new time, so we decrement it. Then we create another function, clearTimer, which will just do clear interval of our time interval. And in a use effect that will be triggered by phase, if the phase changed, or if post changed from our debug UI, then we will call a runTimer and it will return clearTimer so we are sure we clear the previous loop and start a new one. We could have put all the interval within the use effect, but I didn't do this because if you want that the player choose when they end their turn and not use only the timer, you will need to manually call clearTimer and to reset the runTimer manually. We won't do it, but it's useful if you need to. Let's see what we have so far. Let's click on launch. We have start game, setting up the different player. We have the timer decrementing to 1, and we should have a crash. Phase end, because we didn't create that method that handled the logic of the phase end. Let's create it over our timer logic here. Let's start our phase end method. It's a big one, so be ready. New time, it's because we just finished a phase. At the end, when we switch to a new phase, we need to adjust its time to based on what is the next phase. So we switch on which current phase we are ending to perform the right action. If we are at cards, it means the different players choose their card. So we need to perform the different actions. So if it's a punch, we will go to the phase player choice because the player needs to choose which player to hit. Then the new time will be equal to player choice time. If it's not punch, which is shield or grab, we directly go to player action. So we'll call the method perform player action. And we go to the phase player action, which is only the display of what is going on. And the new time is the time of the player action. Okay, then if it's the player choice that just ended, we will perform the player action because now we know which player will be punched, which one has been selected for it. Then we set the phase to player action because it's just after player choice. And we need to set the time to the right one. Then when we just finished player action, we remove the player card because now it's out of its hand and we need to check which one is the new player turn. But if it's equal to the one that started, it means we finished a round. So if we are at the last round, because the state of round is equal to the number of rounds when the game ends, it means it's finished, game over. So we need to know who won. So first, let's calculate what is the player with the higher number of gems. So we go through each player. We check if its number of gems is above the maximum number of gems. If it is, we set max gem to the number of gems of that player. Once we have done it, we iterate through all the players again, and we set them if they are the winner is the one with the highest number of gems. Then, because it's finished, we empty their cards array, but we also do it in the player again, so it's not so important. But now it won't be in the UI. And we set the phase to end because the game is over and we want to display a game over screen. If it's the end of the round, but it's not the last round, we want to start a new round. So if it's next round, we need to change which player is starting the round. So we just increment it based on the number of players. So if it reaches the maximum number, it goes back to 0. That's why we use modulo. Then we set player start to new player start, and we set player turn to the new one. We increment the number of rounds, and we distribute a new card to each player because they all played one card. We need to give them a new one. And we set the phase to cards with the adequate time. And then if it's not the last player time, it means it's the next player. So what we need to do is just set player turn to new player turn. And we just need to check if it's a punch to go to player choice. And if it's another one, we do perform player action like we did before. So maybe we could write it better, but I didn't write it a better way. And we break. The default one is just break because it shouldn't happen. We covered all our different phases. And we set the timer to new time because the variable will be set with the correct time. We use two methods that we didn't create yet. So we have getCard. Let's start with this simple one. What this function does, it's pretty simple. We get the current player that is playing with player turn from our list of players. If we don't find a player, we just return empty. It shouldn't happen, but if we have a disconnection exactly when it happens, it could happen. Then we try to get the cards from the player. If we don't have, again, we have an issue with our network, we return empty. But when everything goes well, which is most of the time, player.getState of selected card to get the index of the card in the hand of the player, and we return the cards at that index. So it's just a nice way to do all the check if an error happens. Then we also need to call the remove player card that we call after a player action. So remove player card, we get the player, we get its cards, its selected card, and from the array, we splice it, we remove it from its array, and we set the state of our player. You see, it's not a global state, it's the player state. We set it with its right cards. Now, last but not least, let's create the perform player action method. What it does, it handles the logic of the card that the player at that turn is playing. So we get the selected card. We could have used our getCard method instead. We define a success that we define at the beginning at true, and if something bad happened, like the player is shielded, we set it to false at the very end. So if the card is not a shield, first thing we want is we want to disable the shield on the player that is playing another card. Because if it had it, we want to remove it, and it's the best way, the best place to do it at the end of its turn when playing a new card. Then we switch based on the type of the card. So if it's a punch, we need to get the target. But if there is not a target, which means the player during the time, I think it's 10 seconds, didn't choose a target, automatically will take the next one after it. And we set on the player a variable named player target with the index of the other player. That's why the order of the players is very important and why we sorted it at the beginning. So the target is equal to players at that very index, and we log that we are punching a target with that ID. But if the target is shielded, then we can't hit it, so we just say it is shielded. So success is false. We will show a fail in the UI and in the 3D board. But if it's not, we need to check if the target has some gems. If it has, we just remove one gem from that player and we put it back to the game state. So it's available in the middle of the game board. And we console log target has gems, so it means it worked. Then if it is a grab, we need to check if there are gems available. If it's the case, we increment the number of gems on our player and we decrement them from the game board and we log grab gem. If it's not the case, we log no gems available for the moment, but we also set success to false. And if it's a shield, we just need to set our player state to shielded. Then at the end of the action, we set action success to the variable success that has been altered when it failed to perform the action. Now we coded for a long time our game engine. Let's see if it works. Of course, I coded it the first time and I had trial and errors and I looked in the console what happened. But here it should work if I didn't do a big mistake. Let's press launch. We can open both consoles. So setting up players, and you can see the logic is only happening on the host. The other one isn't doing this. It will just have access to the variable. So now we have the timer. It's doing a punch on another player. Then it's the next player. So I guess it's player choice. I didn't put the log for it. So I think it's a punch too. So yeah, it's a punch target. Currently, it's just taking the first card. So as we didn't log it, but we can see our loop seems to work. So this one grabbed a gem, the other one is shielding it, next round, and so on. But it's not the best way to visualize it. So let's start by creating our UI. Before doing the 3D, let's do our overlay. If you are not new on this channel, you know we will be using Tailwind to create our UI. If you are new, don't forget to subscribe, but let's install Tailwind with Vite. So let's install the dependencies here. We also need to save them as development dependencies. Yarn add, if you're using Yarn like me, then npx tailwind css init-p, paste it on your terminal. It will generate a config.js file. Let's copy it here. Let's open tailwind config.js. It's the content that changed. It's just to say on which file we apply some Tailwind styling. So index.html and in the source folder, the JSX file and TypeScript if you're using TypeScript. Now we just need to add the import at the top of our index.css. Go to index.css, add those lines. While we are here, go to Google Fonts, choose a font you like. The one I liked was a Rubik Mono 1. Okay, click here. Then select regular. Be sure you only have one. Here at import and copy the URL. On top of your index.css file, add the import. And because we are using Tailwind, we don't need to change it here. We go to our tailwind config.js and in the theme, we add the font family for Sans, Rubik Mono 1, or we fall back on sans serif. We should be ready to go. We can create our new component. So inside components, new file, ui.jsx, export const UI. We'll return null for the moment. Go to app.jsx and next to the canvas, we add our UI component. Now it's ready. Let's create our UI component. First thing we need to do is to get the variable from our hook. We get them from useGameEngine. That's why it exists in the first place. Inside it, we will need the phase. Start game is a function to restart the game. So I don't think we exported it, so we will need to. Timer, player turn, players, round, get card, and action success. So while we think about it, we have the start game. Let's go back to our useGameEngine, where we export the value. We also need to give the start game. And action success, I don't know if it's in the game state or not. It is, so we don't need to export it too. But what we will also need is the get card, which is not in the game state. Head back to UI. Let's get the different values we will need to render our UI to describe what is happening. First, we want to get our current player, which is the one that is playing, not me, but the one which is its turn. So it's players of player turn. We want to get me. This is my player. It's coming from Playroom Kit SDK and it's me on my screen. Then the current card we get from get card. And to get the target, first we need to check if we are doing a player action to display which one is getting hit. We need to also check that it's currently a punch action. And to get the target, we go on players of current player, which is the one which is its turn, and get the player target. As you remember, we said it always have a good value of another player. Now we have all the variables we need to create our label to display what is really happening right now. So let's create a variable named label, and we'll switch on the phase. So if we are currently at the cards phase, what we will display on every screen is select the card you want to play. If it's player choice, it means one of the player needs to choose a target. So if I am the one that should choose a target, I will be displayed on my device. Select the player you want to punch. But for the others, we will display my name is going to punch someone. Then if it's a player action, so it's just displaying what is going on, we will switch based on the different card types. If it's a punch, first we want to check if the action is a success or not. If it is, we say X is punching Y. But if it didn't work for another reason, like if it is shielded or it doesn't have a gem, we say player failed punching other player. Then if it is a grab, again we want to see if it worked or not. So if it worked, we say player is grabbing a gem. If it's not, we say there are no more gems available for X player. If it is a shield, we just say the statement that the player can't be punched until next turn. And by default, we break. Now switch back to the phase switch statement. If it's end, we display game over. Now the fun part, the HTML, I won't go deeply into it. So we have some classes to make it on top of the screen. Then we have a flex box with the padding, so everything is nicely displayed. On the top part, we display the number of rounds on the top left, because we are in a flex container. We display on the right the timer. Here it's a SVG. It's one I found on Hero Icons, which is great if you are using React and Tailwind. So this is the icon, and this is the text displaying the current timer. Then we use Flex1, it's just to space what is on top to what is on the bottom of our screen. And on the bottom, we display the label, what is currently happening. If it's at the end, we display the winner. We loop through each of them. We filter the one that are the winner and we display their name. Then if we are the host and it is the end, we display a play again button and we call the start game method so we can start a new game. Now before doing the 3D part, let's see if it works. So we have round 1 on 3. We have the timer on the top right. We can pause it. So it's not useful right now, but it will be when we will do the 3D. Or it could have been when we were developing the game engine, but because I already did it, we didn't have mistakes. Let's unpause it. So it was select the card you want to play. Now it's avocado is going to punch someone. So it's the select the player you want to punch. It's player selection for this player. Avocado is punching someone. President is going to punch someone. So I guess it's this one because select the player you want to punch. We still have 2 seconds to do it. President is punching avocado. And you can see our game logic is working, but it's not very visual. We need to develop the 3D part. If you are new to React 3 Fiber and want to understand in depth how it works and how to create any 3D experience you have in your mind, I built React 3 Fiber, the ultimate guide to 3D web development, a project-based course covering every aspect you need to know to help you accelerate your learning of Three.js. The link is in the description below. As our game is card-based, let's start by creating a 3D model for our cards. So I prepared something using Blender. It's very simple, it's a plane that I extruded a bit and beveled the edges, but let me show you what is important with it. We have only one mesh, which is named card, but inside it contains 3 materials. So we have one material, which is named borders. It's what is not supposed to have a texture on it. So it's just the card default material. I made it purplish, but you can choose another color if you prefer. I will provide you the Blender and GLTF file. Then I have a front texture. So let's go to edit mode so we can see exactly the size of it. I added some grid to make it a square. So you can see it's a square. It's where we will put the image of the specific card. So the material is named front. If you want to create your custom one, be sure that in UV editing, if you select it, that the UV is set properly. So when you will attach the texture, it will be properly using the texture you attach it to. And then we have the back side, which is a full texture. And for the back, it already contains the right texture we will be using. So I made it using shading. If we go to back, you can see the image I'm using. Now the question is, how do you find or draw images to use? You have plenty of solutions if you are an artist, if you want to purchase it, but now we can leverage AI. What I did is I used a tool named Leonardo.ai. It has a feature with some free credits you can use daily. There are a lot of user-generated content. You can start from it or start by just creating using your prompt and creating a new image. You can see my history here. So you have to be careful about the dimension. Me, I needed a ratio of 1:1 because I generated a square for the card part. Remember that blue part here is a square. I tried many things. You can see my prompt: pirate hiding inside a barrel, anime style horizon. Some were nice, like this one, I kept it. But this one, it has a lot of errors and inconsistencies. This one, I liked it. This one was a bit weird. So you can see I made a lot of trials and error. To see all my errors, you can go to personal feed here, and you can see some were very bad. This looks very different from what I ended with, but at least you can see, even if you don't get it from the first prompt, try harder, use one from the community feed, and start from here to create your own. Let's load the different files inside our project. Go to public, create a new folder, models. We will drag and drop our card GLB 3D model here. Let's drag and drop inside models. So now we have it. We can preview it with that extension. If we switch texture, we can preview it nicely. If you are looking for the extension, it's named 3e from Degrit, and it helps you preview some GLTF GLB file. Then let's create another folder in public, name it, cards, and drag and drop the different cards you generated. I advise you to name it with the name of the card in the game engine. So we have grab, punch, and shield. So it's easier to not have to do a remap, but just use the card name. To generate a component from our 3D model, we can use gltf.permanentDress, the link in the description. Grab your 3D model into it, and automatically it will generate you the component. So you just have to copy it and create your component from it. You can also use the CLI, but sometimes some people have errors, so using the online is a proper solution. So let's name it card.jsx, paste it. You have the preload of card.glb, but us, it's in models. So be sure to adjust the path with the one you have, /models. Let's name the component card, and let's start by displaying it in our experience for the moment. So we'll replace the default mesh with a card. Currently, if we do it, it's all black because we don't have any light. Instead, let's use an environment preset to have some nice lighting effect. We set background and blur to have a background color in our scene. And here we have our card loaded. So the backside is the texture which is inside the GLB. But here we need to replace that part with our different cards and display some text information here. Let's go back to our card. We will change the props. So we'll need the type. By default, we can choose, for example, to be shield, and we'll get the rest of the props. Then when we have the card type, we can use texture to get the texture from the image, so cards and type. So here it's important to have the same name than the cards, what I mentioned earlier. And we know the material that is responsible of the card texture is the name named front. So instead of doing this, inside our mesh, we will create a mesh standard material. We will be using what we had before from materials.front, so we have the same properties, but we also add the texture. And let's be sure to have a white color. One last thing for optimization, if you want to add a loader, you will do useTexture.preload, and you will do it for each type of card. So punch, shield, and grab. Now if we reload, we have our nice card here with the shield. Let's do it for the other ones. Go back to the experience. Position X is equal to -2. Position X is equal to 2. Type, so we have the shield, so we have punch and grab. Let's see if it works. Here we have it. We have the different card types. Nice. So now let's add some text inside our card based on the type. So let's define the different label and info based on the type. We create a new variable named card descriptions. So it has a property for each type of card. Punch. We say punch another pirate, shield protect yourself, grab is grab a gem. Now let's go to the end of our card group. We'll add some text. We need a font, we will download it. We positionate it on the card. Here we display the type to uppercase, so it will be punch, shield, or grab. We add a mesh standard material, and we use the same roughness than the front material, so it will blend nicely using the same settings. Then another text, which is the card description based on the type of our card. We do a failsafe, putting an empty string, but it shouldn't happen. And we use the same material. We could have cloned it, but it's fine here. We don't have a lot of them. Don't forget to do the import, so text from dry. And let's download the font. Go to fonts.google.com or any font you like, Robotos Lab. Go to it and download the family. Because it is a 3D font, we need to really download the file instead of just doing an import like we did in CSS earlier for the HTML part. So inside public, we create a new folder named fonts, and we drag and drop the fonts. We just download it. Now we have done it. One last optimization as we did for the texture. We can do useFont.preload and preload our two fonts. Now we have our cards with the right font and the right text attached to the type of card. Our cards are ready. Let's prepare the other assets for the 3D world. Let's reuse an asset pack that I already used in the responsive tutorial, which is the Pirates kit from Quaternius. Go to download. It's asking it to support it, so don't hesitate to do it. And go to continue to download. From here you have access to all the different type of objects. Go to GLTF and download the different GLTF files you need. I will provide all of them on the GitHub repository if you don't want to search for it. But if you want to customize it, it's here. So let's drag and drop the different models we will be using. So we have the different characters, we have the barrel when we will be shielded, and we have the gem blue, which are the gems available for the players. Let's start by creating our animated characters using those files. We start by creating a component named character.jsx. We do export const character is equal to a component, and we return null for the moment. What we will need inside a character? We will need the index of the character. So let's say it's 0. Because we can have up to 4 players, it will be 0, 1, 2, and 3. The animation, it will come from outside our character. Let's start with idle 1 by default, and we will just need the rest of the props. Then we will have a group, which will take the rest of the props. If we look at our different characters inside the models, the name is always the same. So we have characters underscore the name dot gltf. So first, let's create an array with our different names. So Anne, it will be 0. Barbarossa will be 1. Henry will be 2. And Mako will be 3. Once we have it, we can use useGLTF with our right model using the character at the right index. We get the scene and animations from the 3D model. Then we will need a reference to our character. So the reference, we will attach it to our group, and to render our model, we just need a primitive with the object, which would be the scene. We don't need to do gltf JSX because we won't need an access to every mesh within our model. We just want to play the animations attached to this model. So to get the different animations, we can do actions of is equal to use animations with the list of animation in the gltf and the reference to it. Then in a use effect, which will be triggered when the animation change, we will play the right animation set from the prop. And when it's returned, so when animation change, we will fade out the previous animation. So we have a smooth transition between the different animations. Let's try it to see if we did a mistake or if it's working well. Inside our scene, maybe we can remove the card from now. Let's use the character components. And we have an issue because we are trying to access ref before initialization. Head back to character, and the reference should be defined before, the actions. At the same time, let's also log the different actions. Now we can see we have our character at the index 0. And in the console, we can see the different animations available to us. Perfect. Let's get rid of it, and our character model is ready. Now the character is ready and the cards are ready too. We can prepare the mobile controller that will be displayed on the user screen on their mobile. To do this, let's create a new component. Name it mobile controller.jsx, and let's create it controller. Okay, for the moment, let's just return a group. And inside our experience, we will start to display the right thing. So it will be mobile controller here. Let's go to mobile controller and let's get access to the variables we need to display the right thing to the player. What will we need? So we need us. So to know who we are, we use myPlayer from Playroom kit. We also need some variables from our useGameEngine hook, so the list of players, the current phase, and which player turn it is. We also need to know what is our index within the players list. So to do this, we use file index and compare our ID with the right player ID. We get our cards from our player state, from me. And we are using usePlayersList with true to force a re-render of our mobile controller when any player state change, so we are sure to display the up-to-date values. Of course, don't forget to do the right import, so Ctrl spacebar to do it easily. Let's start by displaying our cards. So inside our main group of our mobile controller, we create a subgroup which will contain all the cards we have in our hand. So we loop through each of them and we display a group which will contain our card, and on click we will set our selected card to the index of that card, so we can select through touching the different cards. Then we render the card based on its type. Don't forget to do the appropriate import here. Now let's try to see if it works. It works, but the position of our camera isn't good. Let's change it. Let's go to app and change the default position to this one, so we are in front of the game. Okay, so now it's a bit better. We should adjust the position of the group to place it down, but we have our cards that we will want to animate based on the selected one, and if we are currently in the cards phase. First, let's adjust the position Y of this group. Let's put it at -1. We can also add some contact shadows for a better effect. Okay, so now we see clearly our cards in front of us, and we can see the shadows slightly here. Now to do the 3D animation of our card, we will be using Framer Motion with the 3D part. So we need to install Framer Motion and Framer Motion 3D. Inside the terminal, yarn add Framer Motion and Framer Motion 3D. Once it's done, yarn dev, and we can hide the terminal. To set up our main config, go to app wrap experience with a motion config with the desired type of animation we want through the whole project. I ended up with this, but of course adjust to what you like and what you prefer. To animate our cards, we will need to know in which state it is. So we declare a variable card anim state. We check if the card is currently selected. If we are during the cards phase selection, so it means our player will have to choose a card. We will change the anim state to card selection. And if our card is currently selected, we will change another animation, which is card selection selected. If we are not at the time to choose a card, we will just change the animation if we are selected, and we will display the selected animation. This is what we'll be able to use to change the different position based on the state. To be able to animate using Framer Motion, instead of using a group, we need to use a motion.group. Generally, the auto import is not working, so go on top and do import and type it correctly, and just wait for Copilot to do it for you. And it's Framer Motion 3D. Now it is a motion group from Framer Motion. We can use the animate property to define in which state we are. So we are using card anim state. And we will be using variants. So our different variants will be the one that are available here. Card selection selected, or just selected. So selected, we will adjust the position, same for card selection, and for card selection selected. Don't forget to import deg2rad from 3matutils. And here we are. Let's reload. We have our different cards. We can choose between one or the others. We have the time to choose our card. And when it's not time to choose a card, it's just displayed on top. And you can see we were using our card, so one disappeared. And now we have drawn a new card because it's the next turn. Perfect. Now to help the player know which one it is on the main game board that we will do later, let's display our 3D model here. Let's start by creating a group and positionate it. We will add the player name, so we'll create a component later with it, and we pass our state profile.name. Then we use our character component that we created earlier, and we loop through all the gems, and we display the 3D model of the gem. So we don't need to create a component, we can use directly GLTF and pass the path to that 3D model. Don't forget to do the right import, and let's create the player name component. On the left, components, new file, player name.jsx. We create our player name component. It takes the name and the font size if we want, and other props to position it. Then we will be using billboard, so we are sure the text is always facing the camera, so it's always readable. Then we use the text with the font size and the font that we already imported earlier, so we don't have to preload it. Now in our mobile controller, we can import it. Perfect. Now we can see our player and our name here. Last thing on the mobile controller is when someone is playing a punch card, we need to select who we want to punch. Below our cards group, let's create a new one. So if the phase is player choice, it's when we need to choose who we want to punch, and if it is my turn, because only if it's me who has to do it, I want to display the choice selection. We will use the center component to center based on what is inside, so the different meshes. Based on the number of players, it's easier to do it. We will map through all our players, and we will be sure that if it's us, we don't render us. Then what we will do is we will positionate our user based on the player index. We need to create a variable, because as we are jumping one index when it's us, it's easier to use a variable outside. Then we positionate it, we animate it. If it is the one selected or not, we will change the variance and put it in front and scale it a bit bigger. Then we display a mesh, a box geometry, to be able to click on a bigger zone than only the mesh. I will show you later without making it invisible. Then we display the player name and the character. If it is the one that is selected, instead of displaying the idle default animation, we'll display no, like if it is asking or begging not to be punched. So now let's go on top and declare our let player index is equal to 0. Because when it will be re-rendered, it will be back to 0. We are sure that inside our map, the order will be correct. Let's try to see if it works. Let's launch a game with 3 players. Do we have a punch card? Yes, here and here. So we need to wait, it's our turn. So here we need to choose if we want to hit President 62 or Cornflakes 95. Perfect. It's working well. Then we have the text, we are punching Cornflake. And then Cornflakes is choosing who it wants to punch. Let's take its revenge. And Cornflakes is punching President 88. Perfect. And President 62 grabbed the gem, so we can see it here. Now, last thing we want to do is, if we don't have enough size, to be sure that we render all our cards and our player name correctly. Let's do a bit of responsive, a very, very basic one. So what we do is we get the viewport using use3 and getting the viewport from it, and we create a scaling ratio based on the viewport width we currently have divided by 3. 3 is the minimum size we want. So if we don't have it, we scale down our scene. So let's use that scaling ratio. We don't want to scale the contact shadow, it doesn't work well, so we will scale down the rest. We'll wrap everything within a group, should be fine, okay. And scale is equal to scaling ratio, fine. And I also mentioned to you, I would show you why we are doing it, so we won't hide the mesh that we are targeting. Okay, so let's try the responsive, and we also want some punch. So if I scale it down, now you can see it's scaling down properly, and we can see everything. So it's grabbing a gem, and now you can see what is the hitbox when we click. So we don't have to be too precise while being on our mobile, but we don't want to see it, so just make it visible to false, but it still catch the touch event. And I think it's good for the mobile controller. Now the best part is to enable the stream mode to create a real game board. To enable stream mode with Playroom Kit, it's very easy. Go to making multiplayer stream mode, and getting started is just when you do insert coin, you add a parameter which is named stream mode true. And when we do this, we will have a new method available, which is isStreamScreen, to know if the current client we are using is the one that is streaming or if it's a mobile controller. Here we have the example of it. So it's in step, do the multiplayer step, and then you have your isStreamScreen. You display what you want. If it's not, you display something else. And here is the example. Let's go to our main.jsx and adapt our insert coin to use stream mode set to true. So now if we reload on the main screen, we will see this. Party maker, invite friends to play together. You can scan the code and see all the players that joined the session. But the way it works is if you use the same URL. So let's open a new tab. It will detect it even if the size is low. It will detect it as a stream mode because it's using the user agent to know if it's on a mobile device or not. So instead, what we can do is to open it like an iPhone 14 Pro Max. If we reload, we will be detected as a player. So we can see here, if we launch, here we are the streamer. So there is nothing for the streamer right now. And here we have the mobile player. But for development purpose, we will hide it and we will do a hacky way to change our user agent. So the little hack I will be using, but you don't have to use it. It's only if you want for development purpose, and me it's for the video recording that I'm doing it. What I do is if window inner width is below 768 pixels, I will change my user agent and fake as if it was the one from an iPhone. So now if I try again, opening it without the inspector, it detects me because this part is small. It detects me as a mobile. Fine, now we're ready to display the game board on the streamer on the left part. Let's create a new component that we will name Gameboard.jsx. As always, export const Gameboard. We'll return a group for now. And in our experience, we'll be displaying mobile controller or game board based on if we are the streamer or not. This is pretty simple. What we do is stream screen from Playroom kit. If it is the case, we display game board component. Otherwise, so using a ternary mobile controller, and we save. Another adjustment we can make using stream screen is in the app. The camera position for the streamer won't be the same than on the mobile controller. The same applies here. Is stream screen. If it's the case, we display that camera position. Otherwise, this one is the mobile one. Inside our game board, we will display everything that is happening in the game, which means the player, the games, and the cards. But we also want a good scenery, a good game board to play with. For the background, we'll be reusing the scene that I created for the responsive tutorial. We'll be using it and place our players here, our deck of cards here, and the different gems here. But this is one GLB we can use to have a ready-to-go game board. You can create your own using Blender and the assets from Quaternius. The game board is available in the final repository. I will give the link to you. You can just drag and drop it inside the models folder or create your own. Let's make it directly responsive like we did on the mobile. So we are using use3, get the viewport, and our scaling ratio this time is based on the basis of a width of 12 on the viewport. So our group will scale it based on the scaling ratio. And inside, let's display our shadow and our game board. To display our game board, we also use only GLTF to load the 3D model because we don't need to do anything with it. We enable cast shadow, we scale it and position it. Then to have nice shadows, we'll be using accumulative shadows component with randomized lights. Perfect. And now we have that nice scene, but you can see we have the shadows that are recalculated every time there is a re-render. This is because the way accumulative shadows work. To do this, let's extract the accumulative shadows and memoize them. What we do is const shadows is equal to use memo, so it won't be computed every time. And inside, we use our shadows. And now we just do this to get the shadows. And don't forget to add an empty array to the list of effects that would re-trigger the use memo. Now the state change, the time change, but we don't have that re-render. We have our nice shadows ready. Now let's get the variable we will need to display our game. So we use useGameEngine to get access to the variable. We need the decks, which are all the cards. We need the gems to know what gems are available. We need the list of players. We need to know which phase we are currently on, and the getCard method to display it. Let's start by rendering our deck. So go after the background, and we create a group that we positionate somewhere inside our game board. We loop through all the cards of the deck with a motion group so we can animate it. We adapt its position based on the index, and we choose an animation based on if it is a player action, and we detect if it's the card that is currently played, so it's the one on the top. It's a fake because it's a card from the player hand, but we are taking it from the deck. It's just to animate it and to make it visual. Then, based on if it is selected or not, we will animate it to the center of the screen and rotate it. Then in a subgroup to do the rotation based on if it is selected, we display our card and we use getCard or undefined to get the correct default value. Let's see if it works with a new session. So we have our cards here. We select different type of cards. And now we have that nice animation showing which card is played. Now let's display the different treasures. So below our deck group, we loop through all the gems and we display the gem model. So it's pretty easy. And because we are using some models, let's preload them. So we have the game board I forgot earlier and the gem blue. So if we want to add a loader and have a nice starting transition, it will be here. Now we can see the treasures in the middle of the screen. If a player is going to grab one, you see it's disappearing. So we need to add our players and do the proper animation to show what is happening. So right after our treasures, we'll have our characters. So we loop through all the players. We wrap them inside a group and we will create a player component because we will need to add some logic here. Let's create our player component, new file, player.jsx, export const player. We'll have the props. We'll return a group and do the import. Now it's time to create our player logic. Actually, the two different props we need is the index to know which character we display and the player. We will need a bunch of variables to create our logic to render our character properly. So first we get them from useGameEngine. We need the phase, which player turn it is, the different players and getCard method. Then we want to know if it is the player turn. So what we do is we check if it is player action phase and if our index, which is the prop, is equal to player turn from the global state here. Then we get the current player, which is playing. So it's players of player turn. Then we want to get the current card. We just call getCard. Check if our player is shielded. We call getState of shield. And we want to check if our player is currently punched. So we need to be at the player action phase and that the current card is a punch. And if the index, so my index of player, is equal to current player.getState, so the one that is playing, and if we are the target of that player. Then we also want to show if we are the winner or not. So we getState winner. And then we want to create an animation based on all those information. So we'll be using a state that we set by default to idle. To compute the right animation at the right time based on all those variables, we are using a use effect based on the current card change, the player turn change, the phase, is player punch or is winner. So by default, the card anim will be idle, but we'll do a condition if it is the player turn. We'll switch based on the current card played. So if it is a punch, the animation we want to display is sword. If it's a shield, we'll do the wave. If it is grab, we'll do a punch. It's because the animation of the player will look like it's grabbing a gem. Otherwise, we do nothing to the card anim. And if it's not the player turn, we want to check if we are punched by another player. So our card animation will be duck. And if we are the winner, we will also be using wave to say, hey, we won. And at the end, when we have computed our animation, we set our current animation to card anim variable. We'll be using a motion group to animate our player. The animation will be set to animate here. So based on that, we can create all our variants. So if it is the sword, it means it's a punch. We will positionate our character at z0.2 and x -1. If it's the wave, it means it's either the shield or we won. So we will scale up our player. If it's a punch, which is the animation, it means we are grabbing a gem, so we go to 0 and 0.4, so next to a gem. If it's a duck, it means we are punched, so we go in front of another player. Then we can display our player name based on player state profile.name on top of the player model. Then we display our character, so it's our reusable component we used on mobile controller. We pass the index of it, we rotate it, and we pass it the animation we computed earlier. We check if our player has a shield. If it's the case, we add a barrel inside it, so it looks like it's protected, like on the card. And we display all the player gems behind it. So we loop through the gem of the player, and we display the same gem that is on the game board. Let's see if it works. Launch a game. And we have our player, so we have shield and punch. But currently our players are here. Now it's a shield, so we can see our player is now shielded. And Cornflake is choosing who it wants to punch. Cornflake is going to punch someone. It's trying, but it failed punching it, but we can see the animation. And now it seems it's working. Let's just grab gems. Now it's grabbing a gem. It's moved from here to behind our character, and it's working nice. But a game isn't a game without nice sound effects. So I'll be using soundeffectlab.info/sound to get some royalty-free audio files. It's coming from a Japanese website to have sounds that you can use within your game. And to get a nice royalty-free background music, we can go to YouTube Studio Audio Library, search for Pirate, and find the one you like. And the one I chose is Drunken Sailor here. Just be sure to go to license type and check if you are authorized to use it or if you need to add credits and so on. Let's add the audio files to our project. Inside the public folders, let's create audios 1 and drag and drop the files you have prepared. Again, I renamed them, so it's named cards, okay, but grab, punch, and shield, so it's easy to use without doing any mapping. For the sound engine, we will do it in the UI, so it's the most convenient way to add a button to enable or pause the audio. We will display it only on the streamer, but you could make it available on mobile if you prefer. Before the return of the HTML, let's create an audio manager with the state audio enabled or not, a toggle audio method that is just changing to true or false if audio is enabled. Then we need to declare all our audio files. Let's load them here on top. So we have a const audio variable which contains a property for each type of audio file. So we just have to grab it and say audio.play. We use a use effect based on if audio enabled change or not. So if it is enabled, we play and we say the background music to loop. If it's not, we pause the audio and we return audio background pause. So we pause it when we change it. Then for the sound effects, we create a use effect based on the phase, if the action is a success and if the audio is enabled or not. So if the audio is not enabled, we return, we don't want to play audio. Then we create a variable audio to play and we do some condition to know which one we want to play. So if it's player action, if it's a success, we'll get the audio to play from the get card, so punch, grab, or shield. Else we will play the fail. So if we fail grabbing a gem or fail hitting a player, then if the phase is cards, we'll play the cards audio, like when we draw the cards. And if we have an audio to play, we go back to the beginning of the audio and we play it. Now to check if it works, we need to use toggle audio to enable the audio, because you need a first user input to be able to play audio on a browser. As we did for the timer, we can use hero icon to find the right SVG to use. Let's go to the end of our JSX here. Let's check if we are at the stream screen to display the button to enable audio or not. We add a button and when we click it, we call the toggle audio method we created. So if it is enabled, we show the right SVG icon. And if it's not, we display the other one. We can now go to app, disable the debug mode and try a game session. Thank you for watching. I hope you enjoyed this video and learned a lot from it. Please consider hitting the like button as it really helps the channel grow and be more visible to other developers. If you have any requests or questions, feel free to use the comment section or join our Discord to get technical help. Don't forget to subscribe to not miss my upcoming videos, but if you haven't yet, I recommend you watch this video here.